It was May 18, 2026, and the rain came down like bad news on a city that had forgotten how to sleep. The neon bled across the pavement. Somewhere above the streetcars and the wet brick, 4 fresh files landed on my desk, each one stamped high severity, each one smelling of shell metacharacters and poor judgment. Tonight was not a night for ghosts in the machine. It was a night for armed robberies. 4 of them. All living in the new alleyways where model context protocol tools shake hands with local code, cloud command lines, science apps, and Git search. The kind of place where a helpful assistant can become a getaway driver if nobody checks what got slipped into the trunk. First case, CVE-2026-7316, CVSS, 73 EPSS, probability 220%. The informant's tip is low but not silent. The informant's tip is low but not silent. The product is alleyways-mcp, affected up to commit 667B914301AD600B38A75, A32026, 7326-26. No KEV listing tonight, so this one is not a repeat offender caught in the act. Not yet. The technical break is command injection, most likely CVE-78 improper neutralization of special elements used in an OS command. The crime scene is the file ater-mcp.py and the code with I component. The attacker manipulates the working dir or editable files argument. Step 1. They send a crafted MCP tool request that asks the server to run the code with I function. Step 2. The server accepts directory or file values as if they are plain paths. Step 3. Those values get folded into a command line for the ater coding tool without safe argument handling. Step 4. The shell interprets attacker-supplied characters as new commands. A path stops being a path. It becomes a loaded gun. The scope is narrow in market share but sharp in blast radius. This is not Apache or Windows. It is a smaller MCP integration for AI-assisted coding, likely deployed by developers experimenting with local or remote MCP tool access. The affected range is all versions or deployments up to commit 667B9143W01 ATA A695, AAW695, AAW6.UAWW6.U8A7. If the MCP server is reachable by an untrusted client, exploitation can be remote and may not need normal user interaction beyond tool invocation. The attacker gains command execution in the security context of the ater-mcp process. In the real world, that can mean stealing source code, dropping SSH keys, modifying a repository, planting a backdoor, or using the developer workstation as a stepping stone into private package registries and cloud credentials. Remediation starts with the people nearest the keyboard. DevOps, security engineering, and developers running ater-mcp should upgrade to the first release or commit after 667B914T301 ATA695, AABAT695, AB3TATAT88. that replaces shell command construction with safe subprocess argument arrays. No exact patched version number was provided in the intelligence file, so treat every deployment at or before that commit as affected until the maintainer publishes a tagged patched release. Short of that, disable the code with I tool, restrict MCP access to trusted local clients only, and block remote exposure at the firewall. Detection means looking for MCP requests where working dir or editable files contain semicolons, pipes, backticks, dollar parentheses, new line characters, redirection, curl, wdet, bash, raw. Check process logs for ater spawning unexpected child commands. But that was not the only body on the slab tonight. Second case, CVE-2026-7220, CVSS-73, EPSS probability 20MJ6. In the suspect is Jack Richard's FastlyMCP, affected up to commit 6F3WWA654FC5654F70fix. NEM76WWW1603, NEM705016, no KEV record, no repeat offender badge, just another armed robbery waiting in the fog. The broken part is command injection again, CWE78W78. The scene is FastlyMCP NEMJS. In the Fastly CLI tool, first an attacker reaches the MCP interface and invokes the Fastly CLI tool. Next, they supply a command value that contains shell syntax, not just a safe Fastly subcommand. Then the node.js server passes that value into an operating system command, likely through child process execution with shell interpretation. Finally, the host runs the injected command with the privileges of the FastlyMCP process. A tool meant to manage edge services becomes a hallway into the host. The affected range is every FastlyMCP deployment up to commit 6F3CC654FC5 bad C5 4FC5 4FC4C4C4C4C4C203 Fastly itself is a major edge cloud provider used by high-traffic web platforms, media firms, software companies, and commerce sites. This MCP wrapper is smaller than the Fastly platform, but it may sit close to powerful API tokens. That is the danger. If compromised, an attacker may read service configuration, tamper with CDN behavior, alter VCL or edge logic, poison routing, expose origin data. Exploitation depends on access to the MCP server or a client that can issue tool calls. If the service is bound beyond localhost or wired into an agent that accepts untrusted prompt content, the robber does not need to kick the front door. He can ask politely from the back seat. The remediation is to move to the first safe release or commit after 6F3WZ6V4FCFWZ6VWC6CWCV360W6V4 FCFW16ZW3CC1W16C03. Again, no exact tagged patched version appears in tonight's report, so security teams should track the upstream repository and pin only to a version that removes shell execution or uses a strict allow list of Fastly CLI actions. As a workaround, disable the Fastly CLI tool, rotate Fastly API tokens, and run the MCP process under a low privilege account with minimal environment secrets. Restrict network access to localhost or a protected management segment. Detection should focus on command fields containing shell separators, unexpected Fastly CLI operations, child processes spawned by node, outbound connections to unfamiliar hosts, and sudden Fastly configuration changes outside deployment windows. I barely had time to light another cigarette when the next file landed on my desk. The weakness is command injection, CVE-78 in mcpserver.py inside the VMD launch handler. The named function is launch VMD GUI tool. The attacker manipulates structure file or trajectory file. Here is the chain. A user or agent sends an MCP request to launch VMD, the Visual Molecular Dynamics application, with a structure file and maybe a trajectory file. The handler accepts those names and builds a command to open the GUI. If it concatenates those values into a shell command, an attacker can add shell metacharacters after what looks like a file name. The VMD launch routine processes it incorrectly, and the operating system executes the extra payload. The lab coat turns into a mask. The affected range is gmx-vmd-mcp up to and including 0.DDO. The software is likely used in a specialized scientific computing context around GROMIX and VMD workflows for molecular modeling. That makes it less widespread than enterprise middleware, but often close to valuable research data, shared high-performance computing environments, and academic credentials. An attacker gains code execution on the host running the MCP server. In a research shop, that can mean theft of unpublished data, tampering with simulations, lateral movement through NFS shares, or abuse of compute nodes for crypto mining. Exploitation may be remote if the MCP server is exposed or if an AI agent can be induced to call the tool with attacker-influenced file names. No user click is needed if the tool call is automated. Remediation is to upgrade beyond version 0.0 once a patched release is available. Tonight's file does not name an exact patched version, so administrators should consider 0.00 and earlier unsafe and monitor upstream for the first tagged version that validates file paths and avoids shell invocation. Short-term, disable the VMD launch handler, require local-only MCP binding, and validate that structure file and trajectory file are existing files under an approved working directory. Developers should use sub-process calls with argument lists and no shell, plus extension and path allow lists. Detection belongs to research IT, DevOps, and security. Review MCP logs for file names containing command separators. Inspect shell history and process accounting for VMD spawning. Curl bash Python NC or chmod, and check shared directories for newly dropped scripts. The night was far from over. Fourth case, CVE-2026-7211, CVSS-73, EPSS probability 220%. The suspect is dvladimirov MCP, affected up to version 0.2020202022 do py search request in mcp server.py, part of the git search API. No KEV marked tonight. This is another command injection break-in dressed as an armed robbery, CVE-78. The attacker manipulates role or pattern. The attack chain starts when a remote caller submits a git search request through the MCP server. The server takes the repository URL and the search pattern, then likely invokes git, grep, ripgrep, or another command line search utility. If repertorial or pattern is placed inside a shell command without quoting and separation, the attacker adds command syntax. The git search API processes it as part of the command line. The shell obeys. Instead of searching a repository, the server runs attacker chosen code. The affected range is dvladimirov MCP up to and including 0.0.0. This tool appears small, but git search has a dangerous job. It touches repositories, clones remote content, and may run near credentials used for private source control. An attacker who gains command execution can read code, harvest tokens from git config or environment variables, alter cloned repositories, or pivot into CI and developer infrastructure. Exploitation can be remote according to the report and may require only access to the MCP endpoint. If an AI assistant connected to this server accepts untrusted instructions, prompt injection could become the social engineer that calls the vulnerable tool. Remediation is urgent for sysadmins, DevOps, security, and the developers who own MCP services. Upgrade past version 0.0 when the maintainer releases a patched build. Since no exact patched version number is in the report, treat version 0.0 and earlier as compromised ground.0.0. Until then, disable git search request, restrict the MCP listener to localhost, block untrusted reportal input, and allow only approved git hostnames. Patterns should be passed as literal arguments, never through a shell, and dangerous characters should be rejected. Detection should include MCP request review for reportal or pattern values containing semicolon, pipe, ampersand, backtick, dollar parenthesis, new line, or redirection. Watch for Git-related worker processes spawning shell, curl, w Python, or outbound traffic to strange domains. 4 cases, same weapon. Different alley. The lesson is plain enough to read under a street lamp. MCP tools are not harmless just because they speak in friendly JSON and live beside an AI assistant. When they bridge natural language to local command execution, every argument becomes evidence. Every file path, every pattern, every command string needs validation, allow listing, and safe process execution. Tonight's takeaways are simple. Inventory every MCP server. Find the tools that call the operating system. Patch when a safe release appears. Until then, disable risky tools, bind to localhost, require trusted clients, strip secrets from the process environment, and monitor child process behavior like a detective watching a hotel door at midnight. The rain will keep falling. The city will keep talking.